Hi, welcome to this recorded talk, but do they understand me? How to make astronomy beliefs visible and what to do when you find out. My name is Linda Shore. I'm CEO of the Astronomical Society of the Pacific, and I want to acknowledge the co-authors of this paper or this talk, Suzanne Girton, Anna Hurst, Kari O'Connell, and Dennis Schatz. The project that we're working on together is funded by the National Science Foundation's AISL division, and it's called the On-the-Spot Feedback Project to Improve Scientist Engagement with the Public. The primary goal of this project is to give scientists tools, approaches, and tactics to help make audience thinking and feeling visible to them. We're working to give them very specific audience probes that they can use that then excite the audience, get them curious, but at the same time illuminate for the scientist where their audiences are. And the ultimate goal is for scientists to use that information about audience thinking and feeling to make adjustments to their activities, to their instruction in the moment. So let's think a moment about the situations maybe that you find yourself in. Maybe some of you lead demonstrations at museums or planetariums. Maybe some of you are used to giving lectures, maybe in a college or a university, or maybe you give large lectures to the public. And maybe others of you teach astronomy in more naturalistic settings. You lead star parties, you take families and show them your telescope and show them the wonders of the night sky, and you show them the moon and Jupiter and the planets. Well, regardless of how you teach astronomy, regardless of your audience, regardless of the venue that you find yourself in, we believe that there's a three-step approach to good astronomy teaching. And it involves first interacting with your audiences, with your learners, having dialogue, having discussion, asking questions, listening to their answers, going around the room, talking to people individually. A second important aspect is to check to see what your audiences are thinking and feeling. And this means literally probing your audiences, asking really interesting questions or engaging them in activities that really make their ideas visible to you, so that you can do the third part of this, which is adapt your lessons and adapt your activities in that moment based on what you discovered your audiences are thinking and feeling. The last one is probably the most challenging and probably the most important. What we're going to be doing in this short talk is giving you one example of how you can use tactics and approaches to find out what your audiences know. So let's look at some examples of the kind of tactics you can use to make audience thinking visible to you. In this slide, we're showing you 5 different tactics or probes that you can use during an activity or during a public engagement that will help make audience thinking and feeling visible to you. You can use a poll of some sort. For example, which shape most closely represents the way Mars orbits the sun. You can show 4 or 5 different orbits, different shapes, and they have to pick one. Using drawings, you can have an audience draw what they think the moon will look like a week from today. Do they have a notion of the phases of the moon, and do they understand how the phases change? You can have your learners build or use models. So here's an example. Using 2 coins to represent the Milky Way and the other coin to represent the Andromeda Galaxy, show me with your hands how far apart you think they are in space to scale. Now, you can even do this in a lecture hall. Everybody's got coins in their pockets. And this is a quick and easy way to just look at an audience and see what they know about these distances. You can use what are called kinesthetic activities, activities that involve moving your body. So for example, with your partner as the Earth, can you be the moon and show me how you move in space during a month? What's nice about kinesthetic activities is while they work for all age groups, they're particularly good for young children who can't always articulate in words what they're thinking, but they can show you with their bodies. You can also ask very open-ended questions. For example, why do you think it's hotter in the summer months compared to the winter months? And this could be an open-ended question where people have to answer verbally. They could answer by writing something down. You can also turn this into a poll, of course, and give them some choices to pick from. But these are all ways that do two important things. Firstly, you get some information on what your audience knows, but all of these questions are phrased in a way that make audiences and learners curious. After you ask this, they really want to know what the answer is. So let's go on and look at an example. So here we go. In this example, I want to show you ways that you can probe for understanding about the size and distance between the Earth and Moon. Why is this important? It turns out for a lot of different concepts in astronomy, having the right understanding of the scale, size, and distance of the Earth and Moon is critical. For example, imagine you're teaching about the phases of the Moon, and imagine that this is the concept that people have in their heads about the size and distance. Let's look at this. The Moon is much too large. It's also way too close to the Earth. If this is the concept you have in your head and you ask people, well, why do you think the Moon changes phase? It would be very difficult to imagine a situation where the Moon isn't in the Earth's shadow. If you're this close to the Earth, you're going to be in the Earth's shadow probably for almost half the month. So if you ask somebody, what do you think causes the phases of the Moon? They're going to say, well, the sun shines light on the Earth casts a shadow into space, and the Moon passes through it. You can now imagine the confusion if you introduce the idea of lunar eclipses and this notion that when a lunar eclipse happens, that's when the Moon passes through the Earth's shadow. Well, wait a minute. That seems to happen all the time, right? Or what if you're trying to teach the geometry of solar eclipses, of total eclipses and partial solar eclipses? Again, if this is the notion you have in your head about the size and distance between the Earth and Moon, this is a very difficult concept indeed. Where do people get this? They get these types of notions often from textbooks that show the distance between the Earth and Moon not to scale. They're not intentionally trying to mislead anybody, but it's very difficult to do the actual size and scale on a piece of paper. Sometimes the internet will show this image, or sometimes the media will. The Earth is actually, if you line 30 Earths up end to end, that's actually the distance between the Earth and the Moon. And the Moon is much smaller. Well, let me show you ways that you can probe for understanding. Here's actually an activity that I do on Zoom to get people thinking about the size and distance of the Earth and Moon. This is a poll, and I show them the Earth on the left, 4 moons on the right. Which moon would you select to be the correct one if you're making a scale model to size? And I let them use their Zoom annotation feature to pick the right one. If this is a classroom situation and you're dealing with people face to face, you can show this up on a screen, have them raise their hands, or you might have them hold up a card. Maybe they have 4 cards in front of them, and each card represents one of those pictures. And you take a quick look at the room, you take a quick look at what they've said on their Zoom annotation, and that gives you a quick idea of how many people in your audience have the right concept and how many need some help. So again, the right answer, lower left. 4 moons laid end to end should give you the right answer, because the moon is 2,000 miles in diameter, the Earth is 8,000 miles, so 4 laid end to end is correct. Now, by doing this activity with the audience, you're doing 2 things that are really important. You're letting them think about what they know. You're sparking their curiosity, because I promise you, once they do this, they're really going to want to know which one is the correct one and if they got it right. And you've started a dialogue between yourself and the audience, and now you can get a better sense of what they know. All right? So let's move on. Now that you have your audience have a better understanding of the size of the Earth and Moon, now it's time for the distance. And again, this is the origin of how people have this misunderstanding about the Moon's phase and thinking it's the Earth's shadow. So now that you have it correct, how far apart should these images be if I want to show the correct distance between the Earth and Moon to scale? So let's take another approach to this. Maybe this time we want to try a kinesthetic activity. Maybe this time we want them to use their bodies. So now I have placed my model Earth on the floor, and I've placed a piece of paper on the floor, and I'm going to ask my audience, this is a smaller group this time. This is very difficult to do if you have a big audience. Maybe these are a group of kids, maybe these are children in your classroom. So you lay out a piece of paper and you say, all right, on the floor is the Earth. You're holding in your hand a model representing the Moon to scale. And I want you to stand on the paper and show me how far apart you think the Earth and Moon should be. All right, so the kids start to stand on the paper, and maybe you get one of these answers. So let's take a look at possible answers. So here we go. So let's imagine this is one of the responses. Here you have your group of children spread out fairly uniformly across the paper. What does this tell you? What does this tell you about this particular group of kids? To me, this looks like random guessing. This looks like a group of kids where nobody really has the right answer, and maybe the people that are really far away from the Earth have some better notion. But here's an opportunity to engage the entire class in an activity, probably a series of activities, that's going to really help them conceptualize the accurate distance between the Earth and the Moon. Not just the number, but conceptualize what that looks like in space. Well, here's another possible response. And actually, I love it when this happens. I love it when the class basically bifurcates, where you have half the children or half the people in your audience thinking one thing and the other half thinking something else. To me, this is an opportunity to break the class into groups, have them talk about why they believed what they believed, and give us some evidence for why they think this. Let them have a debate. And you can still do activities, but I would find this as a really teachable moment. Here's another possible response, and this is one I think you have to be a little bit cautious about. This does happen occasionally, where the vast majority of kids have a pretty solid idea of what's going on. It doesn't happen often, but maybe they just learned this morning in their classroom. But you've got a couple of children that don't quite have it. Be very, very cautious. Don't make that single child feel like they're not smart or they got it wrong and everybody else got it right. It's really important that that child understand that in science, lots of times you don't get the answer, quote, right. Your hypothesis needs some further work, and you change your beliefs once you get new data. You also want them to know that lots of people think this. Lots of people think the Moon is this close. They're not alone. So do take some time to make sure that this one child feels okay, and you can still do the activity. Well, I want to thank you all for coming to this virtual talk. I know it was very quick, and I'm sure you have questions. And if you do, my email is lshore@astrosociety.org, and you can find out more about the Astronomical Society of the Pacific and all of our programs, including this one, at www.astrosociety.org. Thanks.